All right, if I was going to guess at what's the easiest pages over the next few days, this would be my guess, this page. We're doing the same thing we did with arithmetic. We're going to do explicit and recursive routines. The only rule change is that instead of having an add rule, we have a multiplication rules. So we have, we multiply by a, which is our start, right, by our ratio to a power. And again, if your start position is 1 instead of 0, you take your variable, your input, and subtract 1 to back it up 1. And the recursive, you do the same thing. You said, hey, you know what? I have a start position. And then to get my next position, I take the previous position and I multiply it by that ratio. So really all we really need to do is be able to find the ratio in the start, and we're good to go. And I'll show you what we're talking about. So I'm going to go ahead and do these next 4. Alright, so let's get our ratio first. You take your ratio by taking any term. Well, I'll take the 4th term, 48, dividing it by that term in front, 24, and our ratio is 2, which we can see. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, and so on. So I'm going to do my recursive. Alright. And we'll say the first term, which is f of 0, is 3. There we go. And then we're going to say, hey, to get any other term, you take twice the previous term. Done. That's all that means. Alright, I'm going to go ahead and maybe put the explicit over here. Alright, so explicit is just like this, right? So it's going to be this one up here. Alright, so we take our start times our ratio to the power. So we're going to say f of n is equal to our start, which we can see there, times our ratio to the nth term. Alright, and this works out. Alright. If we were going to write a rule, we should probably say over here that n is greater than or equal to, well, 0, and over here n is greater than or equal to 1, because we already have the 0 term and we'll be okay with that. Just really quickly finding the domain of those. Let's go ahead and do this guy over here. Alright, so same concept. We'll take any term, I don't know, let's take our 5th term to get our ratio. We'll say, and divide it by our 4th term. So our ratio is 5, which we can see, right? 1/25 times 5 is 1/5, times 5 is 1, times 5 is 5, and so on. So we'll do our recursive. And we say f of 1 this time. Remember, we started at 1, so we're going to have to back things up on a couple of these. Not this guy. This guy's written the exact same way. The recursive is written the same way. We just define n a little different, right? So I'll say, hey, to get my term, I do 5 times my previous term. If I wanted the 3rd term, I take 5 times this. If I wanted a 4th term, I take 5 times this. And this one will say n is greater than or equal to, well, they already gave us a 1, let's start at 2. Now we'll do explicit here. Alright, we'll say to find our number, we have our start, which is 1/25, times our ratio, right, to the, and this time we got to say n minus 1, because when we plug 1 in, we don't want to change this. We want it to come out as 1/25. And there it is, and we'll say n is greater than or equal to 1. Cool. That's how easy they are. Coming down here, we're going to do a couple more. Come down a little bit, maybe. Alright, so we'll say this guy, let's get our ratio, which is 27 divided by 9, which is 3. Nice and easy. And I'll say recursive. Alright, f of 0 again is 1/27. F of n is equal to 3 times the previous term, that's f of n minus 1. And then we'll say n is greater than or equal to 1, because we already got our 0. Let's do explicit. Turn the So we'll say define our function. We have our start, 127 times 3 to the n. We don't have to say n minus 1 because we started off on the 0 term. We'll say n is greater than or equal to 1. And we could give a range since they gave us a table. We could say n is greater than or equal to 1 and less than or equal to 6. So actually I probably should say that on this guy. So let me put that in the middle. N is greater than 1 and less than or equal to 6 because there was no dot 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 like this guy up here or this guy over here. It's a definite range. I should have done that over here too. Let's keep going. Ratio here. Any term, let's take 1,000 divided by the previous term of 100. Ratio is 10. We got our recursive. Alright. So let's say f of 1 is equal to 0.001. Was that 1,000th? And to find our term, we take 10 times our previous term, f of n minus 1. We'll say n is what? Greater than or equal to 1 in this case. Oh, sorry, we already got 1. 2. Last one, explicit. We'll say f of n is equal to, what we got? We got our start, which is 0.001 times 10 to the n minus 1. Remember, we don't want the first one to change it. We don't want this to be applied, the multiplying by 10, our rule, on the first term. So we have to say n minus 1. And we'll say n is greater than or equal to 1. All right. Let me see what the next two pages. I think the next two pages look like this guy. They do. How much time are we at? This is at 7 minutes. We should be able to get these guys. Let's finish this up. Alright. So if I was going to do this guy right here, this says I can find the terms of a graph. So I'm going to say, hey, n and f of n. And it says that we're greater than or equal to 0. So if I plug in 0, that just gives me 2. All right, I'm just plugging in 1 right there. 2 to the first is 2 times 2 is 4. We can kind of see the rules doubling, right? We're multiplying by 2 every single time. That's our rule. 3 would give me 16. Let's go ahead and graph what we got. Plugged in 0, it's 2. 1 gave me 4. 2 gives me 8. And obviously we don't have enough room to go any further. That's it. We're done. All right, let's try the next one. That's 3. Here goes 4, 5. Oh, that's what, A. So, turn to the next page. Page 4. And give this guy right here. So it looks like this one is starting on 1. So, we'll say n and f of n. Give ourselves a few. We'll go 1, 2, 3, 4. It tells us, uh-oh, I should have put 0 on there. Ah, alright, let's turn that to 0. We'll make this 1, 2, 3. You can pause if you want more time. F of 0 is 16, I can see that there. And this says, hey, to get my next term, I take the previous term and multiply by 1/2. So that's going to go 8, 4, 2, 1. So I come over here, 16, 8, 4, 2, 1. If we want to, we can kind of just slowly approach that axis right there. We're done. Let's get this guy too. Alright. I'm going to do one more, and then I'm going to just underline this, and I'm going to come down here and finish this bottom guy up, and we'll be done. So, this guy starts at 1 by the look of it. So I'm going to say n and f of n. Go 1, 2, 3, 4, and if we need 2 more. Alright, there's my start. So my first term is 3. And it says every time I go to my next one, I double it. There's my rule. You can see it right there. So from 3 to 6. From 6 to 12, from 12 to 24, so on. So we started, what, at 1 was 3. It's right about there. 2 was 6. 3 was 12. And honestly, we're done. We can't go any further than that. So you can graph this guy right here. And let's come down and talk about this bottom part right here. Come down to here. Let's see if I can straighten this up a little bit. And this is a real-world geometric sequence. All right. So I can model a real-world situation with a geometric sequence. Write both an explicit and recursive. We can do that. Let's see, let's write that down here, explicit. And I think we could probably do this explicit. I should probably start with recursive. Recursive. Let's start here with the recursive, and then we'll see what it says. All right. So it says, a type of bacteria divides into 2 new bacteria every 20 minutes. Scientists growing the bacteria begins with 200. How many represent? So we're going to make our n, our input value, our n equal to 20 minutes. So everyone knows, not hours. We're going straight 20 minutes. Makes it a little easier. And recursive would be, well, I guess it's f of 0 is equal to 200. And then to find my next term, I take 20 times my previous term, f of n minus 1. Done. For my explicit, right, I would say f of n is equal to my start, 200 times 2 to the nth power. All right, there it is. And it wants to know how many are present after 4 hours. Ooh, well, let's see. 4 hours, that's going to be 3, so it takes 3 n's to get 4 hours, so I guess n is going to equal to 12. 12 sets of 20 gives me 4 hours. Alright, so I'm going to have to plug in n to get 4 hours. I'm going to have to make n equal 12. So let's come down here and we're going to say n equals 12, because we know 4 hours is 240 minutes, and so is 12 times 20. So here we go. We're going to say f of 12 is equal to 200 times 2 to the 12th. And I've already put this on my calculator. So it's 819,200 bacteria, which is why that exponential growth is kind of scary. And there it is. All right. I think we finished this section, which is kind of nice. I'll see you guys tomorrow.